Can we start?
Yes, we can
Okay.
start now. We can start.
First, who can start? Srikant, Durga, Vijay.
Oh, my name is Divya, not Durga.
Here is showing something different.
My full name is Durga
Okay,
Divya.
Divya.
Yeah.
Okay. Okay, continue. Hello.
Hi.
You can continue. First, introduce yourself.
Yeah, from me?
Yes, ma'am.
Yeah. So, how could I address you firstly? Can I know that one? I should call you as Sir or Rituraj is fine.
Anything. Rituraj is fine.
Yeah, okay. Yeah, good morning to everyone, and thank you for giving me this opportunity. This is Divya. I have completed my post graduation from Vinayana Institute of Technology and Science for Women with an total aggregate marks of CGPA of 8.933, and I have done my major project in embedded systems titled Design of a Multifunctional Android-based Smart Home Controlling and Monitoring using Raspberry Pi. And I have graduated from Princeton College of Engineering and Technology from Hyderabad with an overall percentage of 73.1. And my BTech projects are also in embedded systems itself. And during my post graduation, I have published one paper on my project, which is in AIP conference, which was held by Vardhaman College in 2021. The conference was online itself, and I got the best paper presentation also. I have a
Okay.
yeah.
Okay.
Yes.
Have you done STA?
No, I have not revised STA.
Okay. And A6 flow?
Yeah, ASIC flow.
Can you tell me about A6 flow first?
Yeah, sure.
Okay.
Firstly, about ASIC flow. Specifications.
No. First, what is the ASIC flow?
Should I define ASIC flow? What is meant by ASIC flow?
Mean and just I need to know about flow first.
You can give the tasks to everyone, like they can write on the paper, and after that, one by one, you can take the solutions, right? Yeah, you can write the ASIC flow steps on the paper, and whenever you feel confident, then we will come to that, right? So next, we can come to the next candidate then.
Okay, Srikant. Hello.
Yeah. Am I audible?
Yeah. Audible.
Yeah. Okay.
Okay. Which topic you prefer, DE, STA, or ASIC flow?
Actually, I prepared about the protocols. Actually, I prepared about protocols, AXI, PCI, and
next time, like
next time.
Yeah, this is basics of
okay. Okay, basics of it. So, yeah, digital I prepared not well, but so I will try to answer that questions.
Yeah, Ritu, you can ask the question from digital.
Okay. Can you diff between a fast flip-flop or latch?
Flip-flop or latch? Yeah. So in flip-flop, we can store the values. That means 0 and 1 values will be there, and latch there will be enable. If the enable will be accepted, then the output also will be changed. And where flip-flop will be the, I think, triggered. Those will be triggering process. That means at the passage or clockwise, event based, it will be taken flip-flop.
Can you design a mux using D flip-flop 2 into 1?
Yeah, mux to D
Yeah,
flip
right.
flop.
Okay. Next, Vijaya.
Good morning, sir.
Yeah,
Uh,
you can
uh,
select one topic. I will ask question from them.
okay. So digital and survey log you can say.
Okay.
1 minute, I bring book. Okay, yeah.
Yeah, okay.
So you can come to the next candidate also.
Divya, have you done?
Yeah, I'm almost done. Can you give me 2 minutes?
Jitendra is also there. Jitendra is also there. Vijay is also there.
Jitendra. Okay. Jitendra, you can select one topic. Anyone, DE.
Yeah. First of all, can I introduce myself?
Yeah, okay.
Okay. So, hi Ritu. I am Jiten Lodi. Hope you are doing well. So, I pursued my electronics and communication engineering from RGPV University, Bhopal in 2022. I currently reside in Gwalior. My skills includes like basics of STA, Verilog, digital electronics, basics of system Verilog, basics of UVM, and EDA, BIM editor, GBIM editor. Okay, so like my
Okay.
tool knowledge includes like EDA Playground and Sim, and my projects includes like implementation of clock generation for user provided frequency, user provided jitter, user provided duty cycle. Yeah, and my second project is included implementation of traffic light controller, and my third project is implementation of synchronous and asynchronous FIFO, and my fourth project is implementation of SPI, serial peripheral bus interface, and my fifth
Okay.
project is
Okay. I will ask you from
yeah,
STA. Okay.
yeah.
Uh,
Sure.
what types of path, actually four type of path in ST, right? Can you explain it? And which one we need to consider on as per our timing report?
Like we have data path and we have clock path.
No.
Okay.
Four types we have actually path, right?
Okay. So I am not aware that of. Yeah.
Into out, rag to rag, you are not aware about it.
No. Maybe I forget, but I'm not aware.
Okay. Rag to rag, you know.
No.
Rag to rag path, you don't know.
No.
Register to register, flip flop to flip flop.
Register to register. Yeah. Rest to rest. Yeah.
Rag to rag, I'm asking.
Yeah.
Okay. Okay. Try to flip flop, rag to rag first. And explain me setup and hold equation for both of.
Can I use pant?
Yeah,
Sure.
you can use.
Just draw the equation setup and hold both. Okay.
Okay.
Yeah,
Next
you can
one.
draw it. You can draw it, and we can come to the next candidate. Vijay is also there.
Vijaya.
Yes, sir.
You can draw it. Jitendra, in the meanwhile, draw it.
Yeah. Sure.
Yeah, Vijay.
Okay, you are from the right.
Yes, sir. Digital
Okay.
logs.
Give me a minute, man.
Yes, sir. Yeah.
Yeah. You know about binary conversion, hexa, octa.
Yes, sir. Yes.
Can you convert?
Yeah, yes, yes, sir.
Okay. Binary to hexa. Okay.
Hmm.
10.
10.
1 minute. 10 111
10
01.11.
10 Okay, next. 10
01
point.
01.11. Right?
Okay, okay. Binary to hexa.
Hmm. It's possible or not? First, tell me.
Yeah.
Next, Srikanth, what is your question? Last time.
Yeah, D flip-flop. By using mux, we can create D flip-flop. Yeah.
Show me once.
Oh. So I think, is it visible?
This is for everyone. This is for binary to hexa conversion 10 111 01.11.
Okay, 1 minute.
Can you please repeat again?
10
10 111 01.11.
binary to hexadecimal. We need to convert.
Binary to hexadecimal.
Correct.
Okay. This is a mux
Okay.
actually. By using mux, I create D flip-flop. 2 muxes I am taking.
Okay. Just wait 1 minute.
Okay.
Done.
2. Yeah.
So 5.
Can you? Okay, Srikanth, wait. Divya,
Yeah.
have you done A6 flow? Have you write down? It's not visible. What you draw? First
Is it visible?
step. Not
First
visible.
step.
Can you tell me?
Yeah, okay, wait. So, yeah. First step is the specification in the ASIC flow design. The next is
Okay.
the
Tell me
architecture.
about specification.
About
What we
specification.
need? What is the input for specification?
So at this stage of the specification, we all need the specifications like time, area, power, or speed to, with an for an design in this stage. Next, we'll go to the architecture in the asset flow design. Then later on, we will go to the behavior model where we are going to design from the
Okay. First design specification. After that, you definitely need RTL, right?
so can come again.
After design specification, you done for one step design specification, right?
Design specification, we will go to the architecture,
Okay.
then behavior
No, I'm
model.
asking just basic steps, 5 6 steps only.
Okay,
We have
okay, the
RTL.
specification.
RTL.
Yeah, RTL
RTL
model will
description
have.
is there. What is the
Yeah,
input
RTL.
for RTL? RTL description, यानी कि hardware description language,
Yeah,
right?
hardware description
What is
language.
the input for this particular step?
Simplify this particular step. From the
Okay.
specification it will come.
Okay. For next step, for like after that, we need to functional verification, logical synthesis
Yeah,
is
from
there, right?
RTL model, we will go to the verification where we have in the verification also different verification. Functional verification is there, design verification is there, and some got to know about IP verification even and SOC verification even. There are lot of verification depending
No.
on
I'm not asking about steps and all. I'm asking about inputs only.
only.
Okay, what is PD inputs, PNR inputs? We have in ASIC flow, we have PNR, right? What is the input required for PD? What is the input for synthesis?
For synthesis. Well, we are going to take up the code from the RTL code itself. Then we are going to the netlist, and there we will check the synthesis model
Okay.
of the RTL coding.
What is missing? Like, can you explain what is which type of file we are using in VLSI industry? Like, one I tell you, lib and other files. Can you explain one by one?
No, I didn't come across this one.
Okay, no issue.
Like, find out. Can you just give me? I'll search it later. What did you say again? Can you come
Okay,
again?
got it. Just in ASIC flow, what you've done, first you need to learn what is the input and output for every stage, and what is the content for every stage, for every input, right?
Okay.
Like for design specification, what we need? First, we have customer requirement. As per customer requirement, we need to design specification and all we need to require, right?
Yes.
And inputs definitely required, like UPF, very low.
Okay.
Just read all inputs first.
Okay. All the inputs to the asset flow design.
Oh.
Okay, I'll go through this one.
Have you learned sign off anything?
Means?
In ASIC flow, last stage, like after that we need to sign off stage. No, okay.
GDA, last stage is like GDSI to Foundry, right?
Okay. Have you done Vijay, binary to hexadecimal?
Yes. 5 is point 0.6640 is coming.
0 point
0.06.
0.06. No.
For 0.11, sir, I have multiplied like 16 into 1 into 16 power minus 1 plus 1 into 16 power minus 2.
Okay. I will tell you the answer in the end of
Okay, sir.
interview. Then you can learn again, okay?
Okay, sir.
Okay. Next, Jitendra, have you done reg to reg?
Yeah. Can I show? Like I have done it on the pants.
Show me once.
I need to.
Yeah, you can represent. Present your screen.
So it is visible.
Visual. Good.
Yeah. So I have like take two flip flops, like launch flip flop and capture flip flop. Okay, and I take the clock part delay that is delta 1 and delta 2 here, and I take the clock to Q delay for this launch flip flop, and I take the some combinational delay. Okay.
Okay, in
So
rec to rec,
regarding,
you have wait. Uh,
yeah,
if you have set up violation
yeah,
in this particular rec to rec,
yeah,
then how you resolve it? First, tell me the remedy. Which one you
yeah,
prefer?
yeah, yeah. Like if we have like setup violation, then we
Hmm.
reduce the like data part delay and increase the clock part delay. So how we
This is the
can
equation.
like
Okay, this is the condition. If we satisfy with this condition, RT greater than 80.
yeah, yeah,
Okay, then we don't have
yeah,
setup violation. If we have
yeah,
RT less than 80, then we have setup
yeah,
violation. This much okay.
yeah,
Then,
yeah.
if you have setup violation and this condition is not satisfied, then what remedy you are prefer? You know how to resolve the setup violation. Basics you, I am asking.
Yeah, yeah. I tell you, like we should increase the like clock part delay and reduce the data part delay. So how we can reduce the data part
How you
delay?
reduce?
We use the
I am asking how you
latch and
reduce.
stop. Yeah, in the data part delay.
Okay, this is okay, but how it's possible to reduce? Any remedy?
Like remedy, I tell na. Like we can use in the clock part delay here. We can use the buffers. And in
Uh,
data part delay, we can use the flip flop or latches. So
this one I will see.
yeah, combination part delay of that is decreases.
Okay.
Yeah,
Can you say inside the buffer upsizing the time cell? Which one you prefer? Like net length and tell me first which pin you are checking the setup.
which pin?
Which pin we have? Okay, we have data path like you
Yeah,
are
like
delta one buffer is there, clock to Q is there, combination is there, D pin is there, Q pin is there,
yeah,
right?
yeah.
In which
So
pin you are
here
checking the setup actually?
in the D1 pin, this pin.
How? Tell me.
Like how, like if we check the output.
Okay,
So if we find
okay, first tell me the data path and required path on this particular rec to rec.
data path.
Huh. AT and RT
Yeah,
are tell me now. What? Okay, data path and clock path. Just
I
explain.
I written this equation.
No. I'm not asking about the equation. In this particular diagram, particular
Yeah,
circuit, what you draw, just tell me. Don't be
like
hesitate, man. It's not a company. Okay,
yeah. But
yeah.
yeah,
Be
uh,
comfortable.
I written like there is clock. So there is a clock period for this. Okay. So I written that clock period is minus the setup time is greater than the delta one this clock part delay plus
Hmm.
clock to Q delay plus a
Hmm.
combinational delay. So if this condition is true, then there is no setup violation in this in that circuit. Okay.
Okay.
And I written also the hold equation like delta 1 plus
Hmm.
clock to Q delay plus like TP is greater than, like for the hold violation what we consider like arrival time is greater than the required time. So for the like hold required time is delta 2 plus hold time, because there is no consideration of clock time period in the in the hold time calculation. Oh yes, sir.
Okay. And if you want to give the condition, it's not good. Okay.
Yeah.
Can you Tell me, have you anyone aware about it physical cells,
No.
fabrication steps? Anyone learn lithography, masking?
Actually, was that one?
No.
No. Yeah.
Okay. Or second order effect, what is the channel length, what is dynamic power, static power? No one.
Yeah, dynamic power, static power, I have learned.
Okay. Static power, and can you explain it? Static power, just basic. I know what is the static power and what is dynamic power,
Also,
and how it's
write
come.
the formula in the paper and tell.
Hmm.
Write
What
the
formula?
formula on the pen and paper. Yeah.
No
Okay.
formula. Just I want definition
Yeah,
first.
you can
Yeah,
tell.
yeah, yeah, yeah. So dynamic power is due to the charging and discharging of the capacitors. Okay.
Hmm. Hmm.
And static
Hmm.
power is occur generally in the like NMOS or PMOS.
Hmm.
Because if the NMOS have the on stage, then there is direct path between like VDD to ground. So uh, there is some current flow between VDD to ground. So there is considered as a static power dissipation.
Hmm. Hmm. Okay.
Yeah.
And what about dynamic power?
Dynamic power is due to the charging and discharging of the capacitors in CMOS. And there is one like short circuit power also in CMOS. So when
Okay.
we have the switching between 0 to 1, then there is a short circuit power happening.
Okay. And if you have dynamic power in your design, how you resolve?
Yeah. Yeah, so there is some step like dynamic power is directly proportional to alpha into C into VDD square into frequency. So we can reduce the VDD voltage to reduce the dynamic power, to reduce the switching frequency to reduce the dynamic power. And we have one like alpha. Alpha is the uh, what alpha?
Alpha is a like factor, constant factor.
Yeah, yeah, yeah. Yeah, alpha is something like constant factor. We can also reduce the alpha.
Okay. And one more, I have one more question from STA.
Yeah.
Can you know about skew? Skew,
Skew. Yeah.
latency, uncertainty?
Yeah, yeah, yeah.
Just tell me skew, uncertainty,
So you can make
latency.
a
What is
diagram.
So
latency?
You can make the diagram also.
No, no, just
like
I'm asking basic.
Okay,
I
okay.
am explaining. Yeah, 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 yeah. So skew is nothing but the delta 2 minus delta 1, like clock path delay to the launch to capture minus the clock path delay of launch free clock. So that is the skew for
What is
the
the positive
STA.
skew and
And
negative
the
skew?
positive skew like delta 2 is greater than delta 1, that is the positive skew. And
Hmm.
if it is less than that, the negative
Which one
skew.
is good for setup? Which one is good for hold?
Positive skew is good for setup and negative skew is good for hold.
Positive skew is good for.
Uh, Setup time.
Okay.
Yeah.
So meanwhile,
So
Sir, I got the
Shrikant just write the code of
I got the answer, sir. Uh,
Shrikant
So yeah.
just write the code of synchronous FIFO and pen and paper and
Yeah.
just write a code of synchronous
Okay.
FIFO. Yeah. And
Okay. Well,
Divya will tell us the difference between melee and mode. Just write the points on the pen and paper and then tell. Jitendra will tell us about the difference between combinational and sequential circuits. Write the points on paper and then we will come to us, right?
so I
yeah,
got the answer, sir. Hexadecimal, sir. No. Hello.
Yeah, Rajat, you are continuing or
Yeah,
you
yeah,
don't?
you can continue. You can continue. Just take the answers from them.
Sir, I got the answer, sir. Hex, I told you told for me.
Mm-hmm.
5D point C, sir. Before,
Show me.
yes.
Show me, show me, show me.
1 minute. Camera flip.
नहीं, present your screen. Na?
I'm doing in paper, sir. First,
Okay,
I
anyone
got.
other one got it? 5D.3. Srikant, have you
I
done
am also
this
got.
conversation?
Yes, I am. Yeah, yeah.
Answer?
I also got. Yeah, 5D point C. Yeah, is it visible?
Visible, okay. Durga, Divya,
Yeah.
you got it?
Yeah, I got it. But a little confused too. Is it visible? Visible? Hello?
Mm-hmm. What's your answer, man? Uh, we have mux and demux, right?
Yes, sir.
First, can you draw 16 into 1 mux? Yeah, 16 into 1, 16. 16 into 1 mux using 4 into 1.
Okay.
Everyone.
Okay, sir.
By using 4:1. That is answer. Yeah.
Yes, sir. Sir, I'm visible, sir.
Visible. Okay. Other one done?
There are 5 4:1 marks.
Visible?
Like this.
Okay. Have you know Morris law? Morgan theorem. Can anyone tell me?
De Morgan theorem, sir.
De Morgan.
So we can, yes, I will show you, sir. Fine.
Show me.
No, sir, De Morgan theorem is nothing but like a plus b whole bar turn into the a bar into b bar, and a into b bar is a into b whole bar is turned into a bar plus b bar. It's just the De Morgan.
Yes.
Okay. Can everyone can okay for everyone using net gate? Can you draw the XOR?
And get XOR gate. Okay.
This one, sir.
NAND using XOR. First, tell me how many NAND gates we need to require.
There are 4 NAND gates are required.
Okay, just draw it.
Yeah.
Vijay, what are you doing? Have some question?
No, sir. I am waiting for questions, sir.
Okay. So
It's for everyone, man.
I think
Okay.
5 NAND gates will be used, sir.
Sir,
5 NAND gates for exclusive OR.
exclusive order. Okay.
Just draw it first. Draw it first.
Okay.
Vijay, are you doing something?
XOR, sir. XOR gate, sir.
Okay, great.
I think is it right or maybe by using
Okay,
NAND
Shrikant.
gates?
Wait.
Yeah.
Okay. Can you tell me about a ring counter?
A ring counter.
Hmm.
Continuously, it will use continuously. That means the ring
Hmm.
counter.
Can you and tell me the characteristics of a ring counter?
The ring counter
Counter,
means
register.
yeah, counter. It mainly count purpose. Register will be stored. That means 0 ones will be stored.
This is
Ring
every
counter.
memory we can store 0 1. Flip flop
Yeah.
also is a register. It's a memory, like na?
Yeah.
Huh.
Yeah.
Then what is the difference between flip flop and counter?
Yeah. Counter will be there will be decrement and increment process also there. I think counter with counter.
Okay.
Maybe. Sorry, I think. Yeah.
Can anyone difference between more and Millet?
More and Millet, input
One by
resultant
one.
inputs and past
Wait,
inputs.
one by one.
Okay.
Should I
Okay,
start?
Divya, can you tell me?
Yeah. So Rajita has asked me to write, but I didn't finish writing. Can I just say it?
Sure. Okay. Continue.
Yeah. Okay. So firstly about the melee. Output depends on both input and the current state of the circuit, whereas in More, it depends only on the output of the circuit. And next one is about melee. Is next state is dependent on both the input and the current state, where in More circuit, next state is dependent on both input and the current state. In Melee, outputs are asynchronous and glitches can occur in Melee. And whereas in More, input outputs are synchronous, so glitches can never occur in More circuit. And yeah, that's it about Melee and More.
Okay, and one simple question for everyone. Anyone can tell me the right answer. Which slope is universal slope?
Which, once again, which?
Slope is universal slope.
Flop, sir.
Flop. D flip flop.
Who's Srikant?
Yeah.
Okay, Vijay?
I don't know this answer, sir.
Okay,
No, sir. I don't think
Divya?
there is a universal
I'm also
flip-
thinking as
flip-flop.
D flip flop itself.
Okay.
Vijay, tell me the okay. Tell me the advantage of system Verilog over Verilog. Why we use system Verilog?
Sir, can I show XOR gate?
You can write the points, Vijay. You can write the points.
Okay, sir.
Yeah, this is fine.
And okay, just basic. Can you difference between the compiler and interpreter? Anyone?
Shrikant, you have done the code of synchronous before?
Yeah, I'm trying that one. Yeah, I'm doing.
Okay, just do it and show it.
Okay.
Just last question from my side.
Yeah.
Okay, can you just tell me the digital signal and binary signal? What is it? Anyone?
Digital signal like, sir, only 0 and 1 when input is high, then output also like 0 and 1, sir, only digital signal.
Okay, and what is digital signal?
Digital and binary, sir. Binary signal or binary system, sir.
Binary you done. Okay.
Yeah,
I'm asking about digital signal. We are learning DE everywhere, right?
Yes,
What
sir.
is the actual DE? What is digital signal? Okay, just Google it and learn it. Okay.
Yes, sir.
Data signal is just
Data is
like
represented as sequence of
it is like 0 to 1.4.
This is binary.
Like considered as a 0.
Digital signal, a
This is
sequence of
binary.
discrete values. Like if at all any given set of values is given, it will only take one value from the given set of possible any possible values. Like
Right.
for the one time at a time or at a given time, it will take only one possible value. Is it right?
Right, madam. Yeah, you are right. Is it anything need to ask more or?
Yeah, so I will ask some questions from them.
Okay, because very long, I'm not much closer. You can
Uh,
ask.
so Vijay, just write the code of like D flip flop. You have already written. Vijay, are you there?
Yes, sir.
So which code you have written in Verilog?
Code, sir, I will write D flip flop, no?
D flip flop is over. Okay.
No, no, I will write, sir.
When you will write here, just write it down
No,
firstly.
yeah, yeah.
Okay. Jitendra, just write a code of FIFO or synchronous FIFO. Just
Synchronous FIFO.
yeah, just a outline you can write. Okay. Divya, just tell me the uh, advantage of system Verilog over UVM, over system Verilog over the Verilog.
System Verilog over Verilog. Okay. So when it comes to system Verilog supports the OOPS concepts and all. But when we
Just
come out,
write on the paper and tell me then.
okay. So can you give me a few minutes?
Yeah,
Then
sure,
I'll write
sure.
them.
Shrikant, you are from DV, no?
Yeah.
Okay. So
HMD.
tell me the make a architecture of like system Verilog and UVM. Make a architecture of system Verilog first.
Okay. Yeah.
Is it visible?
Yeah.
Yeah. So when we come to the system Verilog, over the Verilog, in the Verilog we cannot reuse the code again. Your reusability of the code is not supported by the Verilog. When it comes to the system Verilog, reusability of the code is provided without breaking the already working code or any existing one. And whereas it is Verilog is in static nature, and randomization in Verilog we cannot do
What
like
is the advantage
randomization.
of randomization, ma'am?
Advantage of randomization.
And how we do a recycling? You told reusability, right?
Yeah,
How we
reusability.
can do it? How we can do it using system Verilog? There is some concept. Like there is OOPS concept, no?
Yeah, OOPS concepts is
That
there
is for
in which we will come
reusability only.
across polymorphism,
That is for reusability only.
inheritance. Yeah.
So just have the like, just you need to improve the things, right? Okay.
Yeah.
Do you want to make a architecture of like this thing? Architecture of system Verilog?
TB architecture of system Verilog?
Yeah, you can write.
Yeah, sure.
Or UVM you can write. UVM if you possible. UVM you can write. UVM. And then tell me first. Okay, Vijay will tell me. Vijay? Okay, Vijay, just show me the code first. Yeah, Vijay, this is fine. This is for D flip flop. Okay, fine. Vijay, this is code is fine. This is correct. So why we use virtual interface in system Verilog? What do you mean by virtual? Like it can be like real also. Like what does it mean? Your voice is not coming. Your voice is not coming. Okay,
It's muted.
okay. Divya, you want to tell why we use virtual
Yeah,
interface?
virtual interfaces. Whatever the in system Verilog in the TB architecture, whatever we are going to do is it is in dynamical nature only. So if you want to connect anything from the DUV or DOT, which is in static in nature, we need to use the virtual interface.
Yeah, correct.
Where virtual interface will help us to connect the DUV things to the system Verilog TB architecture in the dynamical nature. That's where we will go for the virtual interface.
Correct. There is one physical interface also. Do you know about it?
No, I didn't come
Okay, no
across
problem.
this
Just
physical.
check it once.
Yeah, I'll check the record.
Yeah, Shrikant, show it.
Yeah, UVM and SV architecture I draw.
It is UVM or
Yeah.
both? Okay, both. Okay, great. So
Yeah.
tell me the steps. Just tell me the steps.
Okay. Where in UVM we are having the sequencer driver and monitor to the scoreboard, and we are connecting DUT through interface. So that is the signal where the driver can drive the signal to the DUT. Then those signal will be collected from monitor and we are checking in scoreboard. So as same like this in scoreboard, we are having the generator and this driver. In place of that sequencer, we are having the generator and driver. So here the connection will be made through the mailbox, and with the DUT, the interface is also same as like the UVM also. In UVM, we are having the these which one TLM ports. TLM analysis port and TLM ports will be there.
What is TLM port?
So that is transaction level modeling, I think. Transaction level modeling.
Yeah,
so TLM port is the one-to-one connection, and analysis port is the one-to-many. Yeah.
So can we use a TLM port like in place of analysis port?
No, in place of analysis port we are not using, because monitor to different parts we need to connect scoreboard checkers like that.
Okay.
So TLM, yeah.
So tell me you have done the FIFO project, right?
Yeah.
Tell me you know the architecture of asynchronous FIFO?
Asynchronous FIFO, actually FIFO concept
building blocks.
I always confuse that one, but
no
I will try.
Okay, tell me the difference between synchronous and asynchronous FIFO. Basic difference.
Yeah, synchronous means the all will be in the same. That means same clock. Synchronous. Asynchronous means it will be different at the rate passage at a time, or at the rate negage. That like that asynchronous we will use.
Oh, which is better than? Which is better than why?
For smooth operation, synchronous is better for less consuming. Asynchronous will be taking a more consume, but the number of operations point of view, asynchronous is the better.
There is concept of metastability also. So in this asynchronous and synchronous FIFO. So how will tackle that? And when it will rise?
No, I think.
Metastability you know, no? Metastability concept.
Yeah. I didn't recall that one.
Okay, no problem. We have done the PCI specs also recently, right? So
okay, yeah.
How many layers are there in PCI Express?
In PCI Express, there will be 3 layers. First one is the transaction layer, and the next link layer or data link layer is there, and the final one is the physical layer. So this will be used for connection.
Can you tell the functionality of all the layers?
Yeah, transaction layer is mainly for TLP. That means packet formation. It will be done there. And data link layer is for NAC ACK protocols, and along with the for link connection. And physical layer will be the LTSSM connection is also there. And in physical, again, 2 will be there. One is electrical related, and another one is I think physical logical related link is there. So physical layer has the 2. So in transaction layer, according to type and format, we can decide which type of packet we are sending. That is the main thing in transaction layer.
Okay. Till now, how many how many generations PCI Express are there till now?
Working it is PC5, and development it is a PCI 6.
Yeah. Okay, great. Yeah. Can you name some typical applications of PCI Express then?
Applications, these will be mainly used for fast data transfer. That means high amount of data, and particularly in advanced processor, that is graphical interfaces, next sound cards, GPU like that. They will be
correct,
mostly used
correct.
application.
There is PCIe and there is PCIX. So what is the difference between
Yeah.
them?
Yeah, that is a speed difference is there, and another thing that PCIX is the parallel communication, and PCIe is the serial point-to-point communication. It is.
So which is faster?
Mostly serial is the that means high band due to high bandwidth that serial is faster. If same rating comparison, that parallel is better, but the parallel is having a drawback of that some data will be missing. That means there will be a chance of missing the data.
As well as power issues are there, right?
Oh yeah, that is also there. Power issues.
Yeah, serials taking more power actually. Serials take more power, parallel take lesser power. Yeah.
Okay, yeah.
Okay.
But data will not miss in serial, I think. Yeah, yeah.
There is data conflict are there in the attribution phase. So you know about
data conflict. Attribution mechanism is there. That means, yeah, data conflict.
Okay, no problem. No problem.
No, I.
Just
Yeah.
okay. Jitendra, you are there?
Sir, I am on process. Like I return some of the inputs and I start the code. Here.
Just give me the like rough steps. Tell me about the rough steps.
Like rough step is like first we have module. Inside a module we define all the input output signals, and they use some of the parameter signal, constant signal for the bits or size.
Yeah, just show your code. Also show your code.
Yeah, I written that way. I use parameter.
Okay, why use parameter? उल्टा दिखा रहे हो यार. अभी ठीक था. पहले वाला सही था. अच्छा, why we use parameter? Why use parameter?
Parameter is used for constant signals. Okay, parameter is for like generic code. So everyone wants to change the design or update the design. Then we change the only parameter values. No need to go in depth of the code and change the everywhere value. So
Okay.
parameter is
so
for
you have done SPI also. So SPI, like what is the full form of SPI?
SPI is the serial peripheral interface.
Okay, where we use it?
Like sir, generally we use in the short distance communication in like mobile, TV or laptop also. To like peripherals connection in between like memory devices or input devices or power management ICs वगैरह. Yeah, something.
Correct. So how many signals are there? Tell me the names of different signals of SPI.
Yeah, SPI have the generally 4 signals for one latch. Okay, one like slab. Sorry, So we have like MOSI, master out, slab in. We have MISO, like master in, slab out. We have chip select, and we have clock signals.
Okay, can we have the multiple masters? Multiple masters are
No,
possible
in SPI cases there is one master and multiple slabs.
Okay.
Yeah.
So SPI or I2C which have the like higher throughput? SPI or I2C?
SPI have the higher throughput over the I2C because I2C has the addresses and like acknowledgement bits. So due to which the throughput of the I2C is decreased.
Okay. So what is the like disadvantage of SPI over I2C? Any one advantage, one disadvantage? You can write on the paper. You can think and write on the paper. Then we will come to it. Fine. One disadvantage and advantage of both I2C and SPI. You can write on the paper. Okay. Vijay, hello Vijay. Vijay, yeah, which task you are doing?
So you told for some difference between system verilog and verilog.
System Verilog and UVM.
Verilog, sir.
Yeah, show it. Tell.
So system verilog, we have one data type like logic, but there is no any data type in verilog, sir. And also in system verilog we have like function like queue, structure, enum data types, but these are not in verilog. And also system verilog used for some verification and verilog used for some designing purposes. Yes.
But still, like some points are missing. Some points are missing. You just have to just revise all your concepts. Okay. You have done which projects?
So I have done, sir, that traffic lights and one traffic
UART
light.
you have done? UART basics, you know?
UART, no,
Basics?
sir. UART, I don't know. No, sir.
Okay, leave it. Which other project? Second project?
Traffic light, synchronous FIFO.
Synchronous FIFO. Okay. FIFO. Okay, write a code for RAM. You can write the RAM you have done, no? Single port RAM.
RAM, yeah, RAM, yes.
Single
sir,
port
RAM.
RAM. Write a code. Okay. Shrikant, just tell me the full form of UART.
Okay. Universal asynchronous receiving transmitter. Asynchronous, yeah. UART, I think it will be single master and single slave applications we can use.
What are the different modes?
No,
Single.
I don't know that.
Single duplex.
Yeah.
All these things, right? Half simplex. Half duplex.
Half
Full duplex.
simplex.
Okay, fine. Yeah.
Yeah.
Okay.
Full duplex and full simplex. Yeah.
Okay. What are the different bit in this? Stop, data.
Start, stop. I think like I2C, it is also like that. Address, data. I think acknowledgement.
Parity is
No,
also there.
that is in
Stop, start.
I2C.
Okay.
Yeah.
Can we have multiple masters in UART and multiple slave? Multiple masters is possible.
Multiple masters. UART will be possible. I think that SPI is not possible for multiple masters.
UART is possible.
So UART.
No, yeah, single slave, single port, single master.
Okay, yeah.
Just
UART,
go to it.
single
Okay.
slave, single.
Okay.
Okay. Yeah.
Okay. And what is the measure of like rate of data in UART? What is the like unit what we are using for the like measurement? Okay, sure. Jitendra, you want to tell?
Yeah. So like generally in nowadays UART is using in like a Bluetooth module.
No,
and
what the measurement?
some like
Baud rate.
wireless
Baud rate.
baud rate. Yeah. Baud rate.
Okay.
Bits per second. Yeah. That is the unit.
What will happen if the baud rate of the transmitter and receiver is different?
So there is no transmission between. We have like 10% of durability of baud rate. Like if we have 10% of difference between transmitter or receiver baud rate, yeah, it is okay for the UART. Rather than it is not working.
Okay, Shrikant, tell me the one advantage and one disadvantage of UART.
UART. Yeah. No, that is a single master that is the drawback actually. That is the yeah. If
size is limited, speed is limited. It is for the like, slow communications. An advantage?
Advantage, fast response.
No clock is needed.
No,
asynchronous it is.
No.
Okay.
No
only lesser wires are needed. Only 2 wires are needed, right? Basically. And parity bit is also there.
Parity bit.
Yeah, exactly. So just revise all your concepts. Revise all your concepts.
Okay, that is the thing. I2C is a combination of that SP and UART. No? That is the thing.
Both are different. Both are different.
Both are different. Okay.
Just go through it once.
Yeah.
Just have the basic
Okay.
idea. Okay. Yeah. Jitendra.
Yeah.
Hi, Jitendra. Jitendra, yeah, tell me your question. Yeah.
Yeah, sir. My so advantage of SPI is that like it has the full duplex. So like master and slab, they can read at a time, read or write at a time. Okay. And there is one disadvantage, like if we increase the slab connection, then there is increment of slab select line. So circuitry of that also increases. So that is the disadvantage over the IT.
Okay, get it. Okay. You can add some more points also. No problem. Okay.
Like advantage or disadvantage?
Yeah, both.
You can ask. I can tell. Yeah.
No problem. Just revise it once. And which mock interview have you given the company interview recently? Some company interview?
No, sir. Like clock system, they take only one, and they told for the second interview, but it is not still.
They start applying for the job.
Conducted.
There is RS-232 in UART.
Yeah.
So
Yeah.
can you give me the what is it?
Like RS-232 is like communication for long distance communication, like laptop, like PC or modem. So they are used in, and RS-232 is the like higher speed over the protocol, and it has the less noise. And we use like RS-232, and there is difference between UART is the voltage levels. Like if we have like -3 to 25, -3 to -25, and +3 to +25 for the like RS-232. But in case of UART, there is a less voltage.
Okay, fine.
So that is the main difference. Yeah.
Okay. So Shrikant, you have done the AHB project. AHB.
APB I did. APB. Yeah.
APB. Okay.
APB, AXI, and this one. Yeah. I2C.
Okay. There is. Do you know concept of out of order? What is out of order?
Yeah,
What is that?
Yeah, out of order. If master wants to write the data on the slave, so after completion of that transaction, the slave give response in any order. That means it is not in a serial. So that will be the out of order. So particularly out of order will be occurs in the this write response and read response we will be get there. That means.
So how many channels are there in AXI?
In AXI we have 5 channels. Write address channel, write data channel, and write response channel, read address, read data channel. 5.
One is left. Okay. No problem. Okay. There is a handshake process in AXI. So tell me about it.
Yeah. For every signal there is a 2 signals compulsory are there. Those are the valid and ready. Suppose if master wants to write the data on the slave, when the valid signal will be accepted through the master, then the data will be started to transfer. But the slave will be received when the ready is accepted. So when both valid and ready is accepted, the data transfer and handshake process will be done. Yeah, that is.
Okay, so Vijay, tell me.
Yes. Code I have done, sir. Means I have taken, sir, 4 memory location, and each memory location can store 16 bit of data. Okay, sir. When at the positive edge of clock, I have started the program. If reset is high, then all memory locations should be 0. If else, if then I take else if. Sir. If write is a single port RAM I have done. Okay. If write signal is came, then data is written to the address whatever I given in the test bench. Another if else if write is 0 and read signal is high, then whatever the address I have given in the test bench, that data will loaded to the same port. Means here I have taken same single port RAM, means I have to giving value to the RAM through the single port only. So it is a single port RAM. Otherwise it is like that.
Okay. Jitendra, I have given you some question.
No, sir. It's
Okay,
over.
let's come to Divya. Hi, Divya.
Yeah, you asked me to draw a CTV architecture.
Yeah. So show me the diagram.
Yeah. Is it visible?
Wait. Now, yeah, sure. Just explain the basic point.
Okay. So SVTB architecture consists of generator, write driver, write monitor, read driver, and read monitor, and the scoreboard. Scoreboard includes again reference model and combinational logic. So the in SVTB architecture, everything is it visible? Yeah.
Yeah, it is visible. Yeah.
Yeah. Uh, yeah.
Okay.
Generator will generate the random factors, and it will give to the right driver. So when it comes to the right driver, the function of monitor is only to capture the packets converted to digital, which are done in the interfaces. Okay, so when the monitor captures the uh, digital format and it gives to the reference model of the scoreboard. This whatever it is coming from the right driver or right monitor, it will be taken as the reference output. So what is the function of scoreboard it will compare the reference output to the expected output, and it gives the appropriate output whatever the required design we are doing, or any of the project. Any you can take any project. So this is the function of the scoreboard. It will compare reference model output and the expected output, and it will compare this both and give the appropriate output. So here in scoreboard it will compare here from the output from the reference model, and in the combination logic it will the output will come from the read monitor, and here it will compare and give the appropriate one output. That's about the SPTV architecture.
Yeah. Okay. There is a concept of mailbox. What is it?
Mailbox itself is a class. It will not have any data type, and it will have some functions like blocking and non-blocking, pick, try, and get, and try get, and try picker. These are the non-blocking and blocking functions. And mailbox is which will connect, which will make the communication between the test bench components like generator, monitor, driver. It will make the communication between these components. So in SV we use mailbox for that.
Okay, fine. So tell me do you know about fork and join?
Yes, fork and join.
Yeah. So who will tell me the fork and join? All three is like none is and is also there.
I will tell you. So there are three type of fork join: fork join, fork join any, and fork join none. So in the like we have like a fork join. So inside the fork join statement. So inside the fork join statement is not finished. Then the pointer is not going to the anywhere. Okay, in fork join any, if any statement inside the fork join any is finished, then pointer come out immediately from the fork join any. And fork join none, there is no need of inside the there is no preference of the inside statements inside like in fork join none. Like if we have like higher delay in the fork join inside, then pointer is come out immediately, and it will run outside the statement which have the less delay as compared to inside.
Okay, fine.
Side or something.
Okay, fine. So can we stop the meeting now, or can we do one more session tomorrow? Tomorrow we can do one more session with like different faculty will take. Just let
Tomorrow, which time? Which time it is?
9 p.m. 9. Mostly 9.
For me, sir, different, sir. So next
It
we
will
can
be like we can reschedule it. No problem.
next
Keep
week.
touch. Otherwise, there is one more interview at 3 p.m. 3 p.m. we have the one more interview.